Hello everyone, this is Dr. Michael from MLR Institute of Technology. We are discussing the subject Digital Electronics and Computer Organization. Today's topic is Canonical and Standard Form. We'll see what is canonical form, what is standard form, its advantages and disadvantages. So, here Boolean function can be expressed as canonical form, that is in terms of you have terms, min terms, and then we have max terms, and the general representations we have in terms of sum of products, product of sums. These are the important terms that we consider in the case of canonical form: min term, max term, sum of products, product of sum. To understand this better, let us discuss the examples and then come back to this. Again, in the standard form is actually a simplified version of the canonical form. So, in the canonical form, we have two forms: sum of products, product of sum. A simplified version will also have two forms. SOP stands for sum of products, POS stands for product of sum. Because it is simplified version, it need not contain all the literals. Again, in this case, we will talk about simplifying in terms of min terms, simplifying in terms of max terms. Okay, let us discuss the example. Suppose this is the standard form of a Boolean expression. Standard form need not contain all the variables in a, for example, here you only have A. In this case, B and C are missing. Here, A is missing. So, this is now sum of products. B complement into C, it's a product term. A, single variable, you can also call it as a product term. Plus stands for sum of product. Hence we have SOP, sum of product. So, now let us convert this standard form to canonical form. Standard form is simplified version, canonical form is the complete version. So, if you see, this is the final result. It is complicated compared to the simpler version. Now, let us see step by step how to proceed. So, first here, as we have discussed, we only have A, B and C are missing. Okay, so let us first bring B into it. So, how we can do that? B or B's complement. He is there. The complement of the term he is there is he is not there. He is there or he is not there will always be true. So, a variable and its complement form, you take both and you perform OR operation, it is always true. For example, say you have day and suppose night, only two cases. So, you can say either it is day or it is night. It's a true statement. That is the reason a variable or its complement plus represents OR. B or B's complement is always true, and true is represented by 1. 1 multiplied by anything is the same. So, A into 1 is A. Again, 1 you can represent by B plus B's complement. Now, let us multiply the A inside. A into B gives us AB. A into B's complement gives us AB complement. So, we brought B into this A. Now, let us bring C into this. How? Again, this term you will multiply it with C plus C's complement. So first multiplying AB with C plus C's complement, then AB complement multiplying with C plus C's complement. Now let us expand this. First term you will have ABC, then here second term we will have ABC's complement, then here first term AB complement C, then AB complement C complement last term. Now here let us focus on the second term. Here in the given question, second term B complement C, A is missing. So what we need to do? Multiply B complement C with A plus A complement. So B complement C, we are multiplying it with A plus A complement. So first A into B complement C takes A complement, B complement C. We get the terms. So A was expanded into 4 terms. B complement C was again expanded to actually 2 terms. So the final result will consist of 6 terms. 1, 2, 3, 4, 5, 6. Simply adding both the result that you got for A and that you got for B complement C. Now what we are supposed to do? We have to check whether any of the terms have been repeated or not. So here if you see AB complement C, AB complement C is repeated. You don't need to take it twice. We have already seen Suresh or Suresh. Is Suresh true or true? It's true. If you say I am happy or I am happy, it means you are happy. You don't need to say it twice. Likewise, you can eliminate one term. So the final result will consist of 1, 2, 3, 4, 5 terms. The duplicate element is eliminated. Now, here, if you look at this term, A complement, B complement, C. Complement, you can represent in terms of 0. True form, you can represent in terms of 1. So it's as good as 0, 0, 1. 0, 0, 1, decimal equivalent is 1. Hence you have M1. Next here you have 1, 1, 0, 0. Here you have 1, 0, 0. 1, 0, 0 is 4. Now here you have 1, 0, 1. 1, 0, 1 is 5. Next here you have 1, 1, 0. 1, 1, 0 is 6. Next, all are in the true form, means it is as good as 1, 1, 1, 1, 1, 1, triple 1 in decimal is 7. So, M7. So, now we can represent the result either in this form or you can represent the result in this form. What we are doing here, we are simply adding the terms. Addition you can represent by sigma, hence you can represent the final result in this form also. Now here, why do we have min terms here? Reason is this. Let us take a term, for example, okay, let us take this ABC here, okay. Let us take ABC. Now in ABC, if any one value is 0, 0 into anything is 0. Suppose A is 0, although B and C are 1, still the result we will get will be 0. Right? So, the value is becoming minimum of the 3 elements. Hence, the term is known as min term. So, I hope in the beginning of the video we have seen the terms min term, SOP, that is clear with this example, and standard form. In terms of min terms, the canonical form in terms of min terms or sum of products is clear. Let us see one more example. We have a Boolean expression. So, this is standard form. Now, the question says, represent it in terms of the product of max terms. Express the Boolean function as a product of max terms. Let us look at the final result. You have product of different terms. This multiplied by this, multiplied by this, multiplied by this. You have product of something. Why it is called max? Because plus stands for OR. Now let us understand this with a simple example. Suppose you are coming like this. There are two routes. Either you can take this route or you can take this route. And then you want to reach somewhere. So here, now suppose you are taking any one route is open. Suppose this is open, this route is open. Still you can travel in this path. You can go to your destination. Any one path is open, the output is true. So that is the reason. If suppose you have 0 plus 0 plus 1, x is 0, y is 0, but z is 1, suppose the result is 1. Whichever is the maximum, that we are getting as the output, hence you have the term, hence it is called max term, product of max terms. So again, the other name for this is product of sum. Previous case it was, previous slide we have sum of products, sum of product terms. Now this is product of sum terms. So question says express the Boolean function. This is standard form. They are asking us to write in terms of product of max terms, means they want in terms of canonical form. Simplified version is always standard form, and canonical form contains all the terms. That is, in this case we have xyz, 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 xyz in each and every product term. Each and every term within the values that you are performing the product operation. Okay. So now how to convert this? First, we need to reduce this into this form. How we can do that? Suppose let us take x plus y into x plus z. What do we have? X into x gives us x. X into x is x, we have already seen. Then x into z gives us xz. Y into z gives us x. Next, okay, y into x gives us xy, yz. Using the dominance property which we have seen earlier, this you can reduce to x and then yz. How? You can take x common, then x, if you take 1 plus, if you take x common, 1 plus z plus y, 1 plus anything gives us 1, so you end up getting x. So this expression you can reduce into this form. So now we are going in terms of product of sum. We are moving towards product of sum. Then now further you have to, this term doesn't have z. So now let us include z. How? 2x plus y adds 0. 0 you can represent by z into z complement. Anything multiplied by its complement is always 0. For example, if you take 1 multiplied by its complement, 1's complement is 0. You get 0. 0 you add to anything, you get the same thing. So x plus y, you can write it as x plus y plus 0. 0, you can write it as z into z complement. If z is 1, z complement is 0. If z is 0, z complement is 1. Either of the case, there is a 0. 0 multiplied by anything gives us 0. Hence, this reduction is valid. Likewise, now here in this term, y is missing. So, add y into y complement. Now, again here, similar to what we have done in this case, this term we can further reduce into two subterms. Like in this case, x was the same, but these two got spread out. In this case, x plus y remains the same. These two will appear here. Now what we will do? We will apply the same logic for this. X plus z will remain same, but one place you will have y, another place you will have y complement. Now let us check in this term if there is any repetition or not. So if you see, yes, xyz is repeated twice. So it's enough if you consider only once. Now here in this case, what you need to do, x you will take it as 0, complement you will represent as 1. X complement you will represent as 1. So this is as good as 0, 0, 0, 0, 0, 0, decimal equivalent is 0. Next term, 0, 0, 1, 0, 0, 1, the decimal equivalent is 1. Next, 1, sorry, x is 0, right? X is 0, so 0 complement form, you have to take 1, 0. So this is 2, hence you have a 2 here. For sum of products in the previous slide, we represented by sigma, here we will represent by pi. Now let us see what are the advantages we have for canonical form. It is unique. Only one possible canonical form for a given function exists. Clarity, there is no ambiguity, means you don't get multiple results. Completeness, any Boolean function, however complex it is, can be represented in canonical form. Disadvantages, it is very complex. Let us see the example once again. This was the standard form. This is the canonical form. If you see, this is very small, but this is complicated. Hence, we have, it is complicated. We have the problem, disadvantage, it is complicated. Computation, computationally expensive. Which is easier to calculate? X plus y into z, or this x, this and perform multiplication of all of this. Obviously, this one is complicated. So, computationally expensive. You have to include more hardware to perform the computation. Redundancy. We have seen, you can reduce this one into this. So, there is, okay, there are unnecessary extra terms that we are having in the case of canonical form. Let us look at standard form. Advantages. First of all, simplicity. Like we have seen here, The term is very simple. The standard form is very simple. Next, efficiency, fewer logic gates. Computing this expression, you need one AND gate, one OR gate. Whereas lots of gates are required to perform this computation. Hence, the advantage is fewer logic gates are required. Flexibility. You can perform combination of multiple standard forms because the expressions are very short. An output of one block connected to another block or addition of two blocks, performing OR operation of two blocks. We have that flexibility when we go for the standard form. Disadvantages. Non-uniqueness. You could have multiple answers for the same question. Multiple standard forms for a given function. Incompleteness. In certain cases, even if you try to reduce the canonical form to standard form, the reduction could not happen. The answer, the final result itself is in canonical form and no further reductions are possible. Hence, you may not get complete answers. And ambiguity, non-uniqueness is nothing but ambiguity. You can get multiple expressions for the same function. So, we have seen Boolean algebra, its theorems, properties, and I want you to focus on min term, max term, sum of products, product of sum. We have seen advantages, we have seen disadvantages. So that's all for today's class. Thank you.